Okay, so we're back. So I'll draw my table again, and then we had one rectangle that came out across it like that.
It was halfway.
All right, so we had half the length over here, half the length over here, or half the area, or half the volume, whatever you want to say about it. But she was sort of implicitly, maybe even she directly said it, assuming that the bricks or dominoes that she was using are all completely uniform. So it's not like this half weighs a different amount than this half or anything like that. Yeah. And that's probably a pretty good assumption. All right, how did she figure out what to do with the second brick?
Well, she wanted to add the brick to a total mass of 2. And then you want half of the mass, so 1 to be on the edge of, on this side of the table, and you want the rest of it to be on the other side of the table.
Okay, and can you, what did she do here? What was her approach to figuring out how far you could push out that yellow brick?
Well, didn't she just push it out until it started to topple?
Yeah, that's exactly what she did. But what was when she did the math? What was the math she was doing? What was her approach to finding out how far you could push out the yellow brick?
She was adding up the fractions, fractional amounts.
Okay. Do you remember what she did?
Well, I think when she put on the yellow brick, it was just like this, and then she slid it forward until exactly half the mass was off the table and exactly half of it was on the table.
Right. How did she calculate how much mass was on each side of the table? That's what I'm trying to get at.
2 of whatever units of mass you're using. So the dominoes are each 1.
Okay.
So you have to have 1 unit on one side and 1 unit on the other side.
Right. That's what she needs to do. How did she figure out how far to push out the yellow brick? Using math. So here's the initial picture. Here's the yellow brick initially. And then here's the, I'm going to just draw it on top like this just to be clear which brick is which.
Yep.
Okay. That's with the yellow brick at the edge and then half sticking out. But we could push the yellow brick forward here, right?
Yeah.
Yes.
Okay.
Well, in fact, you want to push it forward because that gives you more distance.
All right, let's ask a simple question here. How much mass is on this side of the line?
Well, we have...
Right in this picture here.
We have 1.5.
1.5 over here.
And then a half over there.
All right. Is that what we're looking for?
No, we want 1 and 1.
Okay, so how do we figure out what to do?
Well,
We
have to slide it over 1/4 because for it to...
Well, but we don't know that. We don't know how far we're going to slide it over.
Well, for however much distance you slide it over, you gain twice as much mass as if you were just sliding 1 domino over.
Ah, okay.
Unless you slide it past the halfway point.
Yeah.
If you slide it past the halfway point, then you've got the same problem on the other side.
Right, actually it becomes an interesting physics problem on the other side. Okay, so you have kind of a hand waving approach here. That if I slide it this way a little bit, so there's where the new line is.
Yeah.
So whatever amount I increase on this side, I lose on this side, and it's the same amount on each brick. And what do I need that amount to add up to? Can you tell me?
You need it to add up to a half.
Okay, so how much is that?
So you need it to be 1/4 of each brick.
Okay, so you can figure out that it's 1/4 of each brick. Okay, now let's dive into this a little more carefully.